IPsec, GRE over IPsec, and all these kinds of things, right? Okay, so today what we are going to do, we're going to discuss about the, look, by default, IPsec works on which mode? By default, IPsec works on which mode? Turn mode, right? Okay, yes, do you remember it? So, when we have studied GRE, okay, let me just open it. So, do you remember the packet size also? Do you remember the packet sizes? It was coming 190 for our ICMP. Okay, if you don't remember, no worries. Today we will capture it again. I will show you. Okay, and it will come around 150 for the EHRP packets. Got it? Now, what was our packets? How our packet structure looks like earlier? I'm talking about GRE. Okay, let's talk about GRE first. First, we'll talk about the ICMP. Okay, we will have the ICMP payload. Then we will have the inner headers. Okay, suppose in the header I have IP 10.1, 10.2. Then what I will have the GRE header, and then I will have a GRE outer header, right? In the outer header, what we will have the public IP 199.1.1 and 200.1.1.1, right? Now, if I will have the GRE over IPsec, then what will happen? Same ICMP payload, then I will have the inner header 10.1, then I will have the outer header 10. Source IP, then the destination IP, then I will have what? My GRE, then what I will have? My outer header, it's the outer header for the GRE, right? Then the same thing, public IP 199, then 200, then what will come in the IPsec? ESP, we are using ESP, we don't use AH. Why? Because AH doesn't provide what? Encryption, right? So we leave that part, then the ESP will come. What this ESP will do? ESP will encapsulate this everything. Okay, we will not be able to see anything when we capture it on the backshelf, right? What we were able to see on the backshelf? Only the outer header information. After the ESP, what will come? Outer header information. Okay, so it will become what? 199.1.1, then the 200.1, right? So everything in the IPsec by default, which mode was running? The tunnel mode was running. Which mode? Tunnel mode, right? We have one more mode. That's my transport mode. If you remember it, what's the use of this transport mode? We use transport mode to we can say if there are duplicacy of outer headers, na? Then we use what? Transport mode. What transport mode will you do? It will check for the duplicacy of outer headers. Okay, right now here we are using what? Same outer headers, right? We are using same outer headers, right? In the GRE outer header, the IP addresses are same, and in the ESP outer headers, the IP addresses are same, right? It is creating duplicacy of outer headers, right? Okay, so what this? Okay, so in the GRE header, what was coming? 199.1.1.1, then 200.1.1 in the outer header. When we started with the when we started the encapsulating with the help of ESP in the IPsec, then that ESP is attaching one more outer header, right? It is using the same outer headers. So what we have here in the packets, we have the duplicacy of outer headers, right? We have the duplicacy of outer headers. So what this transport mode will do now? It will check for the duplicacy of outer headers. If there are duplicacy of outer headers, okay, I haven't. Okay, many. I'm sorry. please tell me if I forgot to share my screen. Just please tell me. Okay. That's why I was thinking that why are you taking so much time to understand these things? Okay. Okay. Let me explain you one more time. So we have talked about that 190 is what? By default ICMP size. Okay. But we will not be able to see the ICMP. Why? Because ESP hides everything. It encapsulates everything. Right? When we start capturing on the backshelf. Right? In the EHRP, it shows. I will show you the trick that how you can capture this. How you will know that this is ICMP, this is EHRP. Okay. I'll tell you. So 150 will be the ICMP, EHRP payload. Okay. This will be the header size for the EHRP. Then we have GRE. In the GRE, what our packet size will look like? ICMP payload. Then the inner header, source IP, destination IP. Then we have the GRE header. Then in the outer header, we have the public IPs. Right? When we are using what? Normal GRE. Okay. When we are upgraded to the GRE or IPsec, then what was happening? Same till the GRE we have outer headers. Then what is adding? The ESP header and the outer header. Okay. But this outer header are what? They are same as GRE outer header. So here we have the duplicacy of outer headers. What? When we are using the IPsec in the which mode? Tunnel mode. Okay. But when we will use the transport mode, now what will happen? Transport mode will check for the duplicacy of outer headers. If there are duplicacy of outer headers, it will remove this header. Okay. Which header? GRE outer header. Okay. Got it? When we will use the this transport mode, I will write it down. When we will use the transport mode, what it will do? It will remove the outer header. Got it? Is this much clear? Which outer header it will remove? GRE outer header. Okay. So this packet size is almost, this outer header is almost of 16 byte. Okay. So from our total size of 190, how much size will come? How much it will drop? 190 minus 16, it will be around 174. Right? It will be around 174 byte for the ICMP. Okay. And for the EHRP, how much? 16. If I will, it will be around 134 byte. Right? This is the thing that we will perform on the transport mode. Is this much clear? Is this much clear? Okay, so let us start with the practicals. Okay, I will not explain you everything now. I will just tell you that what happens in the. Okay, I haven't started the lab. I hope you remember all the commands. If you don't remember the commands, no problem. But I hope you remember the concepts. Okay, caps lock is on. Okay, you are still not okay. Okay, you guys are voting on just give me 2 minutes. I'm coming. Hello. So let us start. Okay, let me do one thing. Let me decrease the size. Okay. Now everything is fine. So let us open all three routers. Okay. I'm gonna do everything in one go. Okay, Manny? So how we're gonna start? We're gonna start with giving the IP addresses to the interfaces. Interface E0/0 IP address 199.1.1.1. IP address n.1.1.1. There are two, three methods. There are one more reason. Okay, that I will when I will give you the notes now. There I will tell you. Okay, that's a simple thing. But the main concept is this only. Okay, the main concept is this, and there is one more reason. I will tell you when I will show you when I will write down the notes concepts. Okay, 199.1.2. Okay. For both the tunnel and transport, there are one more reasons. Okay, that's why we use tunnel and transport. Maybe you have heard it of already. Okay, after that, what I'm going to do, I'm going to create what? Tunnels. Interface tunnel 1, IP address 192.168.1.1, 255.0. Tunnel source was there in the tunnel source 199.1.1.1, and for the tunnel destination, what we have 200.1.1.1. Okay, this is the configuration for the tunnel. Okay, now I have to advertise what? Router EIGRP, let's say 111. Okay, network 192.168.1.0, network 10.0.0.0. No auto summary. Anything else I have to advertise? Nothing else. Okay, now what I'm going to do, I will start for the IPsec. Okay, we'll start with the phase 1. In the phase 1, what we have to call? The ISACAM parameters, right? Crypto ISACAM policy, we have 10. Hash MD5 authentication, fiduciary key encryption triple dash group, I have 2. Okay, exit crypto ISACAM keys Cisco address 200.1.1.1. Okay, now I will call what? The phase 2 ESP parameters, crypto IPsec transform set. I'm giving the phase 2 tunnels name tset ESP triple dash ESP MD5 HMAC. Got it? Now what I'm going to do? I'm going to call one crypto IPsec profile. Crypto IPsec profile, I'm going to name it IPsec IP profile. Okay, then here I'm going to call what? My transform set tset. Then I'm going to call this thing on my tunnel interface. Okay, that will be with the help of command tunnel protection. Then we have IPsec. The name I think IPsec after. Okay, profile I have to give. Then profile. Okay, iProfile is the profile that I created for the ISACAM. So here do show crypto IPsec SA. Okay, no packets has been sent till now. Do show crypto ISACAM SA. Okay, so state is no state right now. Okay, it's not even in the idle state. Why? Because it hasn't made the neighborship. Yes. Okay. Now let us do one thing. Let us. What happened? Yes, I have done, but I think it is lagging. Okay, it has come up. Now let us go interface E0/0 IP address 199.1.1.255.255.255.0. No shut. Exit interface E0/1 IP address. It's 200.1.1.2 No shut. Exit. Do ping 199.1.1.1. Right? So the host name. Let's source name. Let us change the host name as ISP. Exit. Do right. Let us write it. Now what I'm going to do? I'm going to configure what? My R3. What are you doing when you are making the notes? Okay. Enable conf. Are you watching the lectures? Interface E0/0 IP address 200.1.1 255.255.0. No shut. Exit. Interface 2/1 IP address 10.2.1.1 255.255.0. No shut. Exit. IP route 0.0.0 0.0.0 200.1.1.2. Okay. Let me try to ping the public IPs 199.1.1.1. Okay, they are pinging. Okay, my public IPs are reachable. Do show IP and here do show IP route. Do show IP route static. Okay, everything is clear till now. Now what we have to do? We have to all the interface, tunnel interface 192.168.1.2 to 55.255.0. Okay, then I have to define what tunnel source. What is my tunnel source? 200.1.1.1. What's my tunnel destination here? 199.1.1.1. Okay, anything else I have to put it here? Nothing. Okay, router, EIGRP. What's the ES number we have to put there? Do show IP protocol. Yes, 111. Okay, network 192.168.1.0. Network 10.0.0.0. No auto summary. Exit. Okay, it will make the neighborship. Okay, it will not make the neighborship right now. Why, Benny? Yes. Okay, I must. Yes. Why? No, I just configured. Every command is same. It's just the concept here. Commands are okay. Okay, you have to just tell me the concept. That why R3 is not able to make the neighborship with the R1. Yes, on the R1 we have configured what GRE over IPsec, right? So the EIGRP packets are encrypted on the R1, but on the R3 they are not encrypted. Okay, if R1 will send the hello message, it will be encrypted because in the R1 we are using what? ESP protocol, right? On the R3 we haven't configured what? The IPsec, right? Right now ESP we haven't configured, so it is sending hello message without encrypted any packets. But from the R1, it is sending the encrypted hello packets, okay, of EIGRP. Okay, that's why it is not able to make the neighborship. Okay, so we will start with the phase 1 parameters. What's the phase 1 parameters? ISACAM policy. Hash MD5 authentication, fiduciary key encryption, triple S, group, we have exit, crypto ISACAN keys Cisco address 199.1.1. Okay. Now we have to define the crypto IPsec transform set versus the face name key set. We have to define ESP parameters, ESP triple S, ESP, MD5 HMAC. Okay. Now after that I'm going to call what crypto IPsec profile. Profile is the name I have given. So here I'm going to call what my phase 2 name. Now I'm going to call this in the tunnel protection with the help of tunnel protection on the tunnel 1 IPsec profile. What's the name I have given? I profile. Okay. Do show now that you can see EHIP membership has been done. Okay. Do show crypto. What happened? Okay, I'm on to the interface. Do show crypto ISACAN SA. Okay, now the state is my idle. Okay, and the tunnels are active. Do show crypto IPsec SA. Okay, packets are exchanging. My tunnel has been active. How? Which packets are this? I haven't started the ping process. Then how? My tunnel is up. We know now to get the tunnel up, we have to send some packets. How we usually do? By pinging. But what are these packets? You have idea, man. What do you think that which type of packets is let me open the Epic plan. Yes, EHIP yellow packets. Okay, got it. Concepts are simple, man. Okay. So it is sending what the EHIP yellow messages. So if I will capture the packets, okay, everything is working fine, right? So let us capture any packets on the R1. Let us capture the packets. E0/0 R1. Okay, it haven't opened. Okay, so here you can see these are which packets? My EHIP packets. Okay, hello messages. So here you can see what the size is. Size is coming around 150 bytes, right? For what? For the EHIP. Okay, now I'm going to do what? I'm going to ping it. So if I will do the ping, then which packets will come? ICMP packets. Okay, let us try to ping. What is the IP there? 10.1.1.1. So what is 10.2.1.1.1? Okay, so these are what? Let me check. So these are what? My ICMP packets. Okay, size has been changed 190. So this should be what? My ICMP packets, right? Yes. Look, if you don't have any other data, then it will be 190 for the ICMP. Okay, it's fixed. Okay, 190 for the ICMP. Got it? Now what we are going to do? What was our today's task, Benny? Yes. Why we will use the transport mode? Okay. Okay. Help me with the packet flow of this ICMP. Tell me what will the packet flow? Packet structure look like? ICMP payload first will come. Then what will come? So in the inner header we have source IP and destination IP. What's there in the source IP and what's there in the destination IP? Tunnel interface IP. No, I'm talking about ICMP here. Yeah, yes, loopbacks IPs. Okay. Here 10.2.1.1. Okay, and here what will come? 10.1.1.1. Got it? Then what will come? Yes, GRE will come. Then what will come? Outrider. What we have in the outrider? Okay, sorry, I'm sorry. So here, yes, 200 will come. 200.1.1.1. Then what will come? 199.1.1.1. Okay. In the definitions, you maybe have heard of GRE do words. Encapsulate. What it encapsulates? We know GRE doesn't. We know that GRE doesn't perform what? Encapsulation. Yes. In GRE, what we encapsulate? We encapsulate the inner header. Yes, you are audible. In GRE, what it encapsulates the inner header with the help of outer header. Okay. I think internet is. Wait. Hello. I'm audible now? Okay. So here, what I was telling you, that in the GRE, it performs encapsulation. Okay. But we don't know GRE doesn't perform encapsulation for what? For my data. So it encapsulates what? This thing. He just said the inner header. Okay. How it performs the encapsulation for the inner header? By adding the outer header. Okay. With the help of outer header, it performs what? It encapsulates the inner header. Is this much clear? GRE encapsulates what? GRE encapsulates the inner header. How? With the help of the outer header. Okay. Now after the yes, outer header. Outer header will come up now. It is not going independently. Outer header is doing what? It is encapsulating with the help of IP, outer headers IPs. It is encapsulating what? The inner headers. Okay. At the starting, device will check the outer headers information, right? It will not take the inner header information at the starting. So that's why we say GRE what? Encapsulates the inner header information. Okay. Not information, inner headers only. Inner headers IP header. Okay. Now after this outer header, what will come? The outer IPs. Really? ESP will come. Okay. After the ESP, outer header will come. Okay. So it will be like this: 200.1.1.1.1. Then we will have 199.1.1.1. Is this much clear? Okay. Let me remove it this time. Yes. All these packets will get encapsulated. Okay. I'll just. Okay. Let me. Okay. We are not. Okay. Let me use another. Okay, so it will do what? It will encapsulate as this thing. Okay, yes, we will encapsulate all these things. Okay, Now, what we want to do, we want to reduce the size of the packets. Got it? So how we are going to do that? By enabling the transport mode. So there are many other things also. Okay, I will show you and we will move on to the different practicals. Okay. Now, how I'm going to do that? Where I have to do that, Penny? No, we will do it on the IPsec transform set. Okay. Crypto IPsec transform set, ESET, ESP, triple S, ESP, MD5, HMAC. Okay. So here we have what? My tunnel and the transport mode. By default it runs on what? Which mode? My tunnel mode. Okay. Now I'm going to do what? I'm going to do it on the transport mode. Okay. Same thing I'm going to do on the R1 also. Crypto IPsec transform set, TSEC, ESP, triple S, ESP, MD5, HMAC. What will be my mode? My mode will be the transport mode. Is this much clear? Okay. Now if I will see do show crypto IPsec SA. So here if you will see, it is still showing what? The tunnel mode. Do show crypto IPsec SA. Why? Look here also. Tunnel mode, and there is one more here also. Tunnel mode. Why? Do show. We have configured the tunnel mode, transport mode, right? On everything. On R1 and R3 both we have configured transport mode. Basically we haven't done anything on the face on parameters. Na? They are still same. So in the crypto cache, they have still the old information. So we have to do what? We have to clear the cache. Do clear crypto. Okay. So if I will see now, look here. The neighborship is down, the neighborship is up. Okay. Everything is fresh now. So if I will see do show crypto IPsec SA. So here I will be able to see what? The transport mode. Okay. And here also I will be able to see what? Do show crypto IPsec SA. So the transport mode is running. Okay. And there is one more method. Okay. Now I will show you capture the packets. Okay. So here we can see the packet size for the EIGRP is reduced to 134 bytes. Okay. If I will do it, okay, these are the elements of the EIGRP, but you will not be able to see why? Because of this thing, ESP. Got it? Earlier it was coming how much? 150 bytes. Now it is coming 134 bytes. Why? Because my GR is, I will show you from here. Okay. Why? Because this thing has, why this yellow color is still here? Okay, what will happen? This GRE header, outer header has been removed. It is of how much byte? 60 byte, right? So this has been removed. So our EIGRP payload. But how our EIGRP payload? This is my EIGRP payload. Okay, and it is sending 192.168. Suppose it is sending from the R1. Okay, then it is sending from where? On the multicast. Then what will happen? GRE. Okay, earlier what is happening? We have the GRE outer header 199.1.1.1. Then we have 200.1.1.1. Okay, after that what is coming? ESP. Then we have the ESP outer header. Same thing 199.1.1.1 and the 200.1.1.1. Okay, but now what happened? This has been removed. How? With the help of transport mode that we are running on the where? IPsec. Is this much clear? Okay, I will show you for the ICMP also. Earlier, how much the packet size is coming? 190 bytes. Okay, it should come how much now? 174. Okay, let us see. If I will just try to ping it from here. Do ping with 10.1.1.1 source 10.2.1.1. Okay, so maybe these are my what? Look here, how much size is coming? 174 bytes. Okay, earlier my packet structure looks like this thing. Okay, now how it will look like now? Yes, it will remove the GRE header. Let me write it down also so that you can make notes. ICMP 10.1 or 10.2.1.1.1, 10.1.1.1. This is my inner header. Then I will have what? GRE header. Okay, GRE outer header has been removed, so it will come to the ESP. Then the outer header of the ESP, what's that? 200.1.1.1. Then we have the destination IP header. Okay, that's my 199.1.1.1 outer header. Okay, right now my packet size is like this. Okay. GRE outer header. Okay. Yes. We will remove this. Look, we will remove this also. Now, okay, how we are going to remove this? With the help of one concept of SVTI. Why we have created GRE? Because by default IPsec was not supporting what? Multicast. It was running on the unicast. Okay, we want to run what? My dynamic protocols. Okay, as they are not point to point, so we have created one tunnel. On the tunnel, what we are running? Which protocol? My GRE protocol I was running on the tunnel, right? Now I'm going to do what? With the help of SVTI. So what is SVTI? Have you heard it of SVTI? Big. Leave the full form. Okay. We also call it native IPsec also. Okay. So what is the concept of the SVTI? It will remove the GRE. Okay. And my IPsec will work as the multicast. Okay. So right now, still we are relying on the GRE, right? GRE header is still there. In my packet size. Okay. In my packet structure, GRE outer header is still there. Okay. It means we are still relying on it for the tunnel protocol. Right. Now with the help of this SVTI concept, we will completely remove this GRE. Okay. We will completely remove this GRE. Okay. If you will remove the GRE, then what will happen? The GRE header is also of 8 byte. So it will remove. Yes. GRE outer header, we have just removed the outer header. Okay, but GRE is still there on my tunnel. Okay, we are still relying on which protocol? For the tunnel in the GRE. Got it? And GRE header size is 8 byte. From where we can see that? Let me show you one command also. Okay, if I go on to the, okay, it's too much hotspot. Do show interface tunnel 1. So here I can see which protocol is still running. GRE. Can you see? Okay, now I'm going to, there is one simple command. Okay, Penny. It's not too much complex. Nothing is there. Okay, I will have to just go on to the interface tunnel 1. Okay, we don't have to do anything. We have to just write the tunnel mode. Okay, we have to just write down the IPsec, IP version. Which IP version we are using? IP version 4. Same on the other one, I will do the same. Interface tunnel 1. Okay, neighborship has been down. Interface tunnel 1. Tunnel mode. IPsec, IP version 4. Okay, so neighborship has been up. If I first I will capture the packets. Okay, I will show you the size. It is coming around 110 bytes. Okay, no. If I will try to ping now, let me just. We have opened the R3. So packet size is coming how much? 166 bytes now. Okay, I70 packets was how much earlier? It was 190. Then we have removed the outer header. Then it came to 174. Okay, then we have removed what? GRE. Then it came to the 166. Okay, here we have removed what? Outer header of GRE. Okay, then here what we have removed? We have removed completely GRE from our kernel. Is this much clear? Okay, now how I am going to show that we have removed the GRE. From Wireshark I am not able to see, right? Because we are using what? ESP. We are not able to capture the packets properly. Na? ESP will hide everything. Right? Did you got it? Now how? Look, earlier my packet structure was like this. Just a second, let me just move it completely. Now my packet structure was like this. This much has been removed. Okay. Now how my ICMP packets will look like? It will look like this. ICMP 10.1.1.1. Then it will be, or sorry, here 10.2.1.1, 10.1.1.1. Okay. We have removed the GRE. ESP will come. Okay. Now this ESP, we can say the IPsec is supporting what? IP version, or we can say the multicast. Okay. So now the outer header, it will have only the outer header 199.1.1 and 200.1.1.1. Okay. So this much, I have reduced this much packets. Okay. I have reduced GRE. I have removed the GRE and I have removed what? The outer header of the GRE. Now how much the packet I have? Size of the packet I have? It's 166 bytes. Okay. Now if you are going to ask me that from where I can see that GRE has been removed, I have showed you on the interface tunnel 1. What was there? On the interface tunnel 1, if I see that I have the GRE over IP. Okay. Now if I will see now to show interface tunnel 1, so I'm going to see here IPsec over IP. Okay. And there is one more thing. Okay. Now I don't have any outer headers, duplicacy of outer headers, right? The SVTI will come, we will not have the outer header. Why? Because we don't have the GRE. If I don't have the GRE, then how am I going to have the GRE outer header? Okay. But I haven't done anything to the transport mode. Okay, transport mode is still running. But in the operation mode, what it will show? It will show you the tunnel mode. Okay, let me show you. It will show crypto IPsec SA. It is still showing what? Tunnel mode. Okay. Why? Because we don't have any duplicacy of outer headers. Because we don't have the GRE. Okay, if there is no GRE, then how we can have the GRE outer header? Okay. I think there is one more command from where I can see. Yes. But transport mode will active only when there is a duplicacy of outer header. Okay. Otherwise, it will show you what? Tunnel. Okay. And there is one more command from where we can see to show interface tunnel 1. Okay, leave it. Okay. So today what we have done the understand the concepts of the transport mode and the SVTI. What we have achieved from the transport mode, we have removed the GRE outer header, and what we have achieved from the SVTI, we have removed the GRE header. Okay. With the help of SVTI, we have done what? We have proved that IPsec supports what? Multicast. Okay. If you try to Google it, it will show you what? That IPsec supports what? IPsec is multicast or unicast. If I will write it here, so IPsec is for unicast traffic. Okay. But we have achieved what? That IPsec does support multicast with the help of one concept of what we call as SVTI. Okay. Simple thing.